Hi, my name is Marjukka Niinioja, and this is a tutorial on how to use the API Audit in APIOps Cycles. I was requested to do this by an API product manager at a telco company, as they are just creating their own API development guidelines using APIOps Cycles as basis. This video has content I typically use with my consulting customers and also with our APIOps Cycles subscribers. If you need information, help, or inspiration with your API-related efforts, be sure to subscribe to a plan at apiopscycles.com and tell a friend too. I'm going to use the API audit with a real API. It's just something random I picked from the internet related to food and nutrition with machine learning algorithm. This is an API I haven't used before to keep things more interesting. I picked this EDAMAM API because for the first 5 seconds, it looked like a quite well-designed and managed API. The story here is that I'll use the API audit like a buyer would inspect the goods they are about to buy. This is one use case for the API audit. The other is to use it when building or changing an API as an API provider. If you'd like us to do something similar with your API, don't hesitate to chat with us at our website. Let's look at the API audit page and instructions in the APIOps Cycles page. You see, it's right after the build phase, meaning that usually the API has been built before the audit, but not yet published. In this case, we have a published API in our hands because we are the buyers. The purpose of API audit is to make sure the API is publishable, manageable, supportable, safe, usable, and well-designed, so it's easily learnable. We can say that overall, if an API passes API audit, it has good developer experience as well as good architecture. The API is published via API management. This is true. I noticed it by checking a few items in the website code. It wasn't directly visible except from the documentation where some of the parameters were documented as Freescale ID, etc. The API is visible in a developer portal. This is true. The API can only be accessed via API Management Gateway. This we won't know unless we try the API and it leaks some internal addresses where we can try our luck. This is a surprisingly common mistake even with experienced developers when using API management. Rate limits are enforced when requesting the API. Won't know for sure, but as they are using the API management and they are listing the rate limits as part of the subscription plans, I'm sure that's covered. The specification is maintained automatically when changes are done to the API. That we won't know for sure. The documentation doesn't look like it's relying on OpenAPI, so it could be published automatically as part of continuous integration. It has more manually written text and examples. From the source code of the page, I can see that the examples are in fact GitHub gists. Specification for endpoints is validated on every change against standard specification. This means that OpenAPI RAML or some other standard is used. The interface description of this API is validated to be according to that standard. The problem is that if it's not, there is a very good chance that the API publishing via the API management will fail. It might fail even then, because sometimes the API management platforms are installed with a particular version, which supports a particular version of that standard. So you need to always know which tools and which versions you are dealing with when using API management. Specification contains schema for the request and responses. Doesn't look like that. No JSON schema to be found in the documentation. This means that the API consumers must make sure that they do their own validation, but also that the API provider needs to pay extra attention when making changes to the implementation, that they don't break the interface. Automated testing is so much more simpler to do when using schema, at least when it's used correctly and the endpoints are designed smartly. If we look closely at the examples, we'll see something interesting. All the concepts have an ontology reference with all. But that would only help if in understanding, so to speak, the meaning of relationship. For example, the measurements used and validating that the value is valid and found in the ontology, not validating the full data set. Request and response schema and examples are validated for format, and examples pass the schema validation. This is again false, as we don't have the schema here. Really often we find when looking at our customers or third-party APIs that the examples are wrong format-wise. Sometimes, of course, include also incorrect data. This makes it very hard for API consumers to start using the API. The API uses HTTPS, or in special cases, other stateless protocol with encryption. That's true and important for security. Even websites should use HTTPS nowadays. Tiny little detail is the all reference that uses HTTP. In case a web page or JavaScript client would use this response as is, it could cause a security problem and alert about unsecure elements, which would block loading those elements on web page. The old reference is probably not the biggest problem from UI point of view, but still. The API is published under the organization's official domain. This is true. This is important for branding, looking reliable, and remembering the address of the endpoints for humans, but also important when handling SSL certificates, firewalls, and other network security aspects. Visible domain is shared with other APIs, so the domain that the API consumers see. This is true. All three APIs use the domain, only the final path of the API is different. This is again a developer experience thing as well as manageability. Sometimes APIs that are implemented on microservices have subdomains that are generated automatically, and this causes headaches for network management as well as developers if it's visible even after the API is published via the API management. Endpoints are max 2 resources deep. Example, projects and ID/tasks ID. In this case, the endpoints are not modeled as individually identified resources, but use more complex searching with multiple identifiers and keywords. They could have also done an endpoint for each identifier, but instead have chosen to expose the parser of their search engine as the one endpoint. This is most likely a good decision for their intended value propositions as shown in the Showcases tab, for example, food diaries. Other naming styles in the style guide have been applied. We don't know if they have their own style guide for designing APIs, but there are some irregularities with API design here in terms of the APIOps Cycles default design guide. The resource names are one thing, but otherwise nothing major, just that some of the attribute names have been shortened. This is sometimes a chosen strategy to keep the URL length shorter, at least in the endpoints that use GET requests with search criteria as query parameters. While the browsers can nowadays handle extremely long URLs, there is bound to be some layer somewhere in code or network that doesn't like super long URLs. With the full recipe analysis endpoint, the values of the attributes can be quite long text too. It's very common to design this type of API with post request, especially in this case when the result is a natural language and ingredients-based nutritional analysis of the submitted recipe, and the request and results are cached. A good example of pure parameters used with the GET request, as has been done in the full text analysis endpoint. The API has versioning, not visibly. They're using an API management solution, so the versioning is possibly implemented inside the API management solution and controlled by the subscription mechanism. This goes to the next point. Versioning strategy is best for the selected API management platform and for the primary API consumers. Yes, probably true in this case. The API uses stateless processing, so no sessions. Looks like that based on the documentation. What you request is what you will get each time, and the API backend won't remember what you did before. This is good, less room for inconsistent behavior and data. There is no special processing like asynchronous events handled. True. GET requests don't have request bodies. True, this is according to standard. Not all API clients support GETs with bodies, and it's not standard implementation according to the RFC. Post is used for creating and updating data. It's not applicable for this API. Post is used only in standard ways. In a way relevant, as mentioned, they do use post for the very complex and variable-rich queries. This is non-standard but very commonly practiced and a good choice if you really must do a complex search. But you should always think about the real need to do that carefully because it may result in complex logic, access rights, and performance issues. Put is used to create or replace entire resource. Well, this is not applicable. Delete is used only to remove a resource, not applicable. 404 is used for wrong URL, yes, according to the documentation. 400 responses have additional information of the specific error. Well, interestingly, they haven't documented 400 status code to be used at all, so possibly they don't validate the query parameters. I'm assuming the result is just 404 or 200 if there's nothing as result because of wrong parameters. Here we have a potential problem because 400 or 204 status codes are not used. Now they do use 422 for unprocessable entities. This is interesting and most likely chosen because they are handling natural text and trying to grasp the meaning. Sometimes the text may include, for example, characters that are not possible to parse. Let's get back to this part later when we are dealing with more OWASP security issues. 401 response is used when API consumer is using wrong credentials. According to the documentation, it isn't used, but as this API and its credentials are managed by an API management solution, I'm betting that the response is actually 401. Let's try. Yep, I was right. This is included in the OWASP security checklist criteria, and it's important that your API backend responds with 401 to the gateway too, if the credentials are not correct. It's also a usability issue to understand what went wrong. If the API is authenticated with a token-based system and uses refresh tokens validated at the gateway, the 401 code also tells the API management to try to refresh the token. Another OWASP criteria. 403 using endpoint which is valid but not accessible by the requesting API consumer or trying to use operation that they are not allowed to do. It's important to make sure that any endpoints the authenticated user is not allowed to use are secure and respond with the correct status code. According to this API's documentation, this status is not used. As they have grouped endpoints belonging to the same subscription product into a separate API with its own subscription, that is probably not relevant. This item in the audit is an example where the collecting requirements business impact template is mapping directly to the API implementation and this audit checklist. So be sure to check that part of the APIOps Cycles method. 500 response when there is an internal processing problem which API consumer cannot fix by changing the request. This status code is used almost as default in most server and gateway implementations. It's not documented in their API documentation, but most likely would happen. The problem usually is that API responds with 500 to all errors, or at least too many errors, and even those which are the API consumer's fault, where 400 would be more appropriate. 500 responses have application-specific error code, but not a very clear plain message about exact error. For example, stack trace or error text, which could expose internal implementation to API consumer. I won't try to break this API right now, but hopefully this is okay. This is part of OWASP requirements. If the error message exposes stack trace or too much details about what the API is implemented on and what exactly went wrong, it could provide a hacker details on how to improve their attack and use known vulnerabilities. Get requests 200 OK and items array as empty array. This is one of the success status code items. There are more listed here. The API in question offers only 200 OK for anything that is not clearly a mistake. Get 204 empty response, nothing in the body. So no 204 for empty responses available in this API. What if the ingredients submitted don't have any nutritional data associated with them? I don't know if there is any situation where the response would be totally empty, but if that would happen, I wouldn't know if it was my mistake or like there's no data or if it's just okay. Post requests. 200 OK for updates or submits without creating new resources. This is okay because they are not actually creating new resources, just caching results of analysis. 201 responses combined with the identifier of the created resource, not applicable to this API. Delete 204 OK when removing resource was successful, not again applicable. As you can see, there are a few more interesting items left on the checklist. These are the ones that you kind of have to experience to truly value someone's experience and tips on them. Both areas in detail will be covered in the next APIOps Cycles Community Pro and Partner newsletters available for subscribers at the end of July 2019. And you'll get some other goodies too, so be sure to subscribe. And of course, subscribe to this channel too.